So I draw for my graph, right? And this is with the graph paper. So why you see me color boundaries in a yellow and the cumulative frequency in blue is to match with my cumulative frequency table that I had. So all my yellow, which is the X, the boundaries, go on the X axis with the boundaries. All the blues go with the Y's, and the Y's is the cumulative frequency on my Y axis. Right. So the first point I'm going to plot is this one. 14.5, 3. So I have to look for 14.5 on the x-axis and match it where I've said 3 on the y-axis. Good. So we're looking for 14.5. So we're looking for 14.5. But where exactly is it? I'm going to show you how to do it. So 14.5 must fall somewhere between 10 and 15. But on which line exactly? Right? I'm zooming it up for you. So what I need to do is to count how much space is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 spaces there. Right? And then I'm going to divide this number of space by my scale. So space, you can't see this. See there? Space divided by scale. Right? So when I counted the space was 10. And my scale on the x-axis, remember, it was 5, right? It's all the way over here, so. See there? Which part is it? See there? 5. So dividing the 10 by the 5. So it's telling me 5 into 10 goes 2 times. So what this is telling me is that every little 2 dots, every little 2 space is worth 1. So from 10, count 2 space with me. 1, 2. So this is going to be 11. Right? Count 2 more spaces from 11. 1, 2. This is going to be 12. Count 2 more spaces from 12. 1, 2. This is going to be 13. 2 more spaces from 13. 1, 2. This is going to be 14. And if you count the 2 more spaces from the 14, 1, 2, you end up getting 15, right? So that's how we read the scales. So we're not looking for 14, we're looking for 14.5. See there? 14.5. So 14.5 is halfway between 14 and 15. So halfway between 14 and 15 is on this little line here, so, right? So what I'm going to do is to take my ruler and my pencil and draw a little faint line on that line. Right? A little faint line. So see my 14.5 there? I'm drawing a little faint line on it. Like so. So I found my 14.5 on the X. I need to find the 3 on the Y. So I have to go over to the Y axis. Go over to it and look which part 3 there. 3 is supposed to fall somewhere between 2 and 4. But exactly where? Again, you have to do space divided by the scale. Remember, our scale was 2. See it up there, so 2 units. So I now have to count the amount of space between 2 and 4. Check it out. 1, 2, 3, 4, 5. There are 5 spaces. So there's 5 space equal 5. And remember, I'm dividing the space by my scale. So space divided by scale. And remember my scale was how much? It was 2 from up top. See there? 2. So if I divide 5 by 2, I'm going to get 2.5 or 2.5. So if I think about it, if I count 2.5 of these little squares, I should get what? Watch me now. 1, 2.5. So 3 is somewhere right there. So what I'm going to do now is to take my ruler and my pencil and draw a faint line, horizontal line, parallel line right across. Right? More you can see this. See there? So I go and draw my faint line right at the point where I just make with the tree and draw it horizontally across. See there? There you go. Nice. There you go. So you see which part it meet? The tree, which part the tree meet with the 14.5, I go and put a bright dot right there. Right there so. Right there so. See there? And remember, we use pencil and draw a graph here, not pen. So right there so. So that would be my first point on my cumulative frequency ogive when I'm plotting it. So next thing now, I have to look for the 19.5 and the 7. A 7? Look. Yeah, the 19.5 and the 7. Right there so. So 19.5 is somewhere between 20 and 15. I remember me said that every little 2 is 1. So I can count it up, right? 15 and 2 give me 1 there so. 2 more give me 1 there so. 2 more give me 1 here. And 2 more give me 1 here. So this going to be 16, 17, 18 and 19. Or if me did want to do it quicker, I could have said, alright, if 2 are 1, like if 2 units or if 2 jump make 1, I could have go so from a 20. 1, 2 and get the 19. But remember, the 19 we are looking for now. We are looking for 19.5. So 19.5 is halfway between the 19 and the 20, which is on this line. So I'm going to take my little ruler, I'm going to draw a faint line, go up on this line. There we go. So remember now, you know, so the 19.5 is matched to the 7. So I have to go and find 7 on the y-axis. So we come back over to the y-axis. And we know that 7 is halfway between 6 and 8. And remember we say is every 2.5 on the y-axis give us 1. So this is 1, 2.5. So my dear so. Right? That will give me the 7. So now remember I'm going to draw my line from the 7 to go across to touch the 19.5. Carry this over a little bit for you. Remember the first line where you did draw, this one go up so, is 14.5. So you have to carry this now past the 14.5 to touch the 19.5 here so. So I'm going to put a bright dot right there so. So you get the drift? And then we can finish it up. So I've went ahead and put in all my points, right? The 14.5 with the 3, the 19.5 with the 7, the 24.5 with the 13, the 29.5 with the 18, and the 39 or the 34.5 with the 20. Good. So I went in ahead and I put in all of those. But if you look at it, my cumulative frequency curve must touch the x-axis. So we need another point out here. Right? Let me draw back for our cumulative frequency table. If I was supposed to think about the class that's supposed to come before this, or the mid or the boundary that is supposed to come before this, notice what number do I add to 14.5 to get 19.5? What number do I add to 19.5 to get 24.5? When you check it out, it's going to be the difference between that, which is 5. So I need to subtract 5 from 14.5 to tell me what the previous class would have been if it had existed. And when I do the subtraction, I would get something like 9.5. So remember, 9.5 is this imaginary class boundary that would have existed, but it don't exist. And the fact that it don't exist means that the frequency is going to be 0. So 0. Alright, great. So our frequency going to be 0 and our cumulative frequency going to be 0. So if I was supposed to plot another point with x and y, remember my x-axis is my boundary and my y-axis x-axis is my boundary and my y-axis is my cumulative frequency. So it would have been 9.5 and 0. Watch me now, watch me. Watch what I do. I draw a curve. Curve, it must be smooth. See there? Nice and smooth and curvaceous. Yes, yes, like that. See? Nice smooth curve. So yes, now we have successfully drawn our cumulative frequency ogive or curve. I would say it must look smooth and curvaceous. It should look like a weird looking S-Lini kind of something, right? So now let's make some sense out of it. So in class, we've been talking about the spread of data, like the quartiles and the percentiles and all of that nicety-nicety-tiles kind of thing. So remember that when we're talking about quartiles, it really splits the data into 4 equal parts. So my Q1, which is my lower quartile, is 1/4 of the total frequency, the total population, total sample size. Words like that could pop up. My median or my Q2 or my second quartile is half of my population, my sample size or total frequency. My upper quartile, which is my Q3, and remember, if it's quartile, it means we're dividing by 4, and it's the upper quartile and it's our Q3, we will multiply by 3. So the fraction for our quartile or lower quartile is 1/4. For our median, it's 1/2 or 2/4. And for our upper quartile, it's 3, which is the Q3, is 3/4. So if I'm going to find my lower quartile, my Q1, to find my Q1, I have to have my Q1 fraction. And remember, we're finding the Q1 position. Q1 position. That is going to be my total frequency, call it TF for now, divided by 4, right? And if you want to put the times 1 at the top, no problem. So my total frequency was, looking at the graph, is where the graph stops here on the y-axis. So the total frequency would have been 20. And if you look back at our graph, total frequency 20, total cumulative frequency 20. So to calculate where my Q1 would be, it would be the total frequency, the 20, divided by the 4. When you check it out, you're going to get 5. So now, to find out what the actual Q1 is, I have to look at my graph. So I have to find where 5 is on my graph. So remember, on the y-axis, no. So 5 is halfway between 4 and 6. I will say that every 2.5 give us 1 on the y-axis. So 1, 2.5. This is where 5 would be. Now what I have to do with that 5 now, that is where my Q1 would be located. That is the vicinity where it's going to be. But I need to find the actual value of the Q1 now. So what I'm going to do, I'm going to find the 5 and I'm going to draw a line to come right across and touch the cumulative frequency curve that we just drew. So I found the 5 and I'm drawing it across to touch the cumulative frequency curve right here. So see there, right here. So this is where my Q1 would be. To get the actual value of the Q1, I have to draw a vertical line come down. Where touching the curve, I have to draw a vertical line come down. So you're going to come down and touch right here. So, and the value that it touched down here, so that is my Q1 value, which is right here. So if I'm reading my graph, it's going to be 17. Remember, every 2 make 1. So from the 15, 1, 2, that is 16. 16, 1, 2, give us the 17 right there. So that is my Q1. So my Q1 is equal to 17. So now it's time for me to find my Q2, right? So remember, what fraction represents my Q2? Is a half. I remember the Q2 is the same thing as the median, right? Think about it. Median quartile, second quartile, second come with the number 2, quartile out of 4. So I have to write down the position first. So my Q2 position, I write it for you. See here, Q2 POS for position, is 2 times the total frequency over 4. See? Second quartile. Remember now that my total frequency was 20, from before. So I replaced in the TF, total frequency, with the 20, and I follow in the formula, putting it back over 4. 20 times 2 give us 40, 40 over 4. Follow in the formula. 4 into 4, 1, 4 into 4, 1, remainder nothing, and 4 into 0, 0. So my Q2 is located at 10 on my cumulative frequency section of my graph. So I'm going to look for 10 on the graph on the y-axis. So this one easy. We can't just read it off the graph. So the 10 there. So I'm going to use my pencil and my ruler and draw the line from 10 to touch what? The cumulative frequency curve. Like so. Where it touches the cumulative frequency curve, I'm going to draw a vertical line, go down. Somewhere like here, so. See there? Right there, so. Then now, what I'm going to do, label it. This is my Q2 position. Q2. There we go. Now to read the actual value of Q2, I have to come to the x-axis to read it off. So remember we said that every 2 makes 1 on the x-axis because of the scale. So I'm here at 20, 21, 22, 23. So this line is somewhere between 23 and 22. What is halfway between 22 and 23? 22.5. Very good, you guessed it right. So look now, my Q2 is going to be equal to 22.5. There we go. And I think I can see that. But see here, 22.5. You calculate Q3 and tell me what you get. So remember, Q3 is our upper quartile. So Q3 or third quartile. So first thing we have to find the position where it is. And because it's our third quartile, it's going to be 3 out of 4. Third quartile. 3 out of 4. I'm going to multiply that by total frequency. Right? So remember, total frequency was 20 from before. So I'm replacing the TF with the 20. And following my formula, it says divide by 4. Divide by 4. 3 times 20, 60. 3 times 0, 0. 3 times 2, 6. Good. Following the formula, divide by 4. Now, through me remember my multiplication table. I'm going to show you one quick way with me do this, right? 4 into 4 goes 1. 4 into 6 goes 1. Remainder 2. I mean, each on the 2 upon the 0 up here, so this number now becomes 20. Short division. You remember it? And 4 into 20 goes how many times? 5 times. So 4 into 60 goes 15 times. So my Q3 position is my 15th cumulative frequency. So I'm going to go search for my cumulative frequency on my graph for 15. Easy cheese, no? So where's 15 on my graph? Where would it fall? If I did say 14 between 16, you're good. That is perfectly correct. So between 14 and 16 will be 15. So remember, on my y-axis, every 2.5 make 1 because it's the amount of space divided by the scale that we're using. So let's count it. 1, 2.5. Right here, so 15 is going to be right there, so remember the next step. Draw for your ruler and draw a horizontal line from the 15 that you found to touch what? To touch the cumulative frequency curve. There we go, right there. Then now I'm going to label it. That's my Q3. Q3. Now to find the Q3 actual value, I must read it off of the x-axis. So I'm going to take my pencil and my ruler and I'm going to draw a line, vertical line this time, from that point to touch the x-axis. So it stops right here. So remember now, reading my scale. Every 2 on the x-axis gives me 1 unit. So from the 25, 1, 2, give me 1 extra unit, which is 26. So my Q3 value is going to be 26. I'm going to put it in here. See that? 26. Right there, right there. See there? Right here, so. So if you look at it, look over here, so. See my Q1 here, so. From here, so, come down. And see my Q2 here, so. My shade it go up. See there? See? This and this look like the same amount of space, don't it? Right? I'll go up some more. My Q3, right here, so. See there? When you look at it, the same space, don't it? And the last one, see it up here, so now? The same space, don't it? 4 equal spaces. So that is what our quartiles do. Divide the data into 4 equal groups. So remember, Q3 is our upper quartile. So Q3 or third quartile. So first thing we have to find the position where it is. And because it's our third quartile, it's going to be 3 out of 4. Third Sometimes CXC like to ask some pretty questions, you know. They will ask you, what is the interquartile range? So the interquartile range, which is the IQR, me write it up here, so interquartile range, your IQR, is the value you get when you subtract your Q1 value from your Q2 value, right? So IQR is Q3, take away Q1. What did we get for Q3? 26. Take away, follow my formula. What did we get for Q1? See it here? 17. I'm going to drop my 17 right here. So my interquartile range is 16 take away 17, which is going to give me how much? Sometimes CXC So when I do the subtraction, I'm going to get 9. So my interquartile range is 9. But CXC like for the sometime is to throw in one extra word pan you said this semi-interquartile range. But I'm going to write it over here. So your semi-interquartile range. And when you think about it, the word semi really mean half. So all you're going to do is divide the interquartile range by 2. You're splitting it in half, so to speak. So if you want a formula, it's going to be Q3 take away Q1 all divided by 2. And if you really want to work it over, you can work it over. But I'm not going to do that. So we know that our interquartile range was 9. And I'm dividing 9 by 2. 2 into 9 will give me 4. Remainder 1 over 2. And you're done. And sometimes CXC like to ask about percentile. So remember, percent means out of 100. So instead of a quartile now, we're having a percentile. So with the quartile, we have to divide the total frequency, the total population, the total sample size by 4. But this time we deal with percentile, so we're not going to divide it by 4 though. If percent means out of 100, it now means that I'm going to have to divide my total frequency by 100. So if I'm talking about percentile, I'm going to write it for you. Percentile. So I'm dividing my total frequency by 100. So out of 100. So CXC could ask you something like, what's the 10th percentile, right? So what I'm going to do is find 10%, which is 10 divided by 100 times the total frequency. And remember, the total frequency in this case is 20. So I'm going to have 10 over 100 times 20. Then I'm going to reduce. This 0 can cancel this 0. So a 0 at the top cancels a 0 at the bottom. If you now have a 0 at the top and you now have a 0 at the bottom, you can't cancel it out because we're basically dividing by 10. 10 into 10 goes 1 time and 10 into 100 goes 10 times. Now 10 into 10 goes 1 and 10 into 20 goes 2 times. So my 10th percentile would be located at 2 on my cumulative frequency axis. So I'm going to look at my cumulative frequency axis and find 2. Whoops, it drops right there. Easy for me, so I don't have to be working out which part it would be. So I find the 2 and I draw it come right across to touch the cumulative frequency curve, just like when we were doing the quartiles. So this is my 10, where my 10 percentile is. So now I need to read that graph off, that point off of the graph. Draw a vertical line to touch the x-axis. Then now I need to read what that value is, right? So here, so it's 12. Between 12 and 13, and here says 13. Between 12 and 13 is going to be 12.5, right? But this is halfway between 12.5 and 13. See that? So halfway between 12.5 and 13 is going to be 12.75. So my 10th percentile will actually give me 12.75. And that's it. Another question that we could ask is this one. What is the probability that a student chosen from the class will get a score of 21 or less? Now what do you think you're going to do? Well, when you look at the graph, or before you reach the graph, when you look at the cumulative frequency table, you can't find a 21 score. You can't find one 21 score. So that means that we have to go look at the graph. So this is where they're testing to see if you can read the graph and make sense of the graph that you drew. So the score, and remember our score is within the boundaries. So we need to look for 21 on the x-axis where the boundaries are. So I'm looking at my boundaries and I'm finding 21. So remember, every two on the x, every two of the little box them on the x-axis makes 1 because of our scale. So 1, 2 from 20 will give me 21 right here. So now what I'm going to do is basically the reverse of finding this interquartile range, the reverse of finding the quartiles and the percentiles. So this time I'm moving from the x-axis to the y. When I was doing the quartiles and the percentiles, I moved from the y-axis to the x. Now to do probability, I have to move from the x to the y. So now we'll find our 21 is right here. So we draw a line from our 21 to touch the curve right there. So where it touches the curve, I'm going to carry it across to touch the y-axis. Ooh, right, to touch the y-axis right there. So when you touch it there, so when you look at it, that number, it's above 8, and we said that every 2.5 on our y-axis will give us 1. So when you check it out, 1, 2.5 right here. So where the line touches over here, so is less than 9. It's less than 9 but more than 8. When you check it out, it's somewhere between half and 8 and 9. So halfway between 8 and 9, well, in a halfway, you know, is a little bit less than half, because half would have touched it, right? Yeah, for real. So it's a little bit less than half, right? Half would have been somewhere up here, so a little bit more than it. But we can read it off and call it something like 8.5. Somewhere right there. So 8.5. You think we're done? We're not done yet. So the probability is a fraction. So you have to put this 8.5 out of the total frequency that is there. So the probability will be the 8.5 out of the 20. So when I'm going to write it on my paper, it's going to look like this. See here? 8.5 out of 20, and that is the probability. That is all. And you're finished. So this is saying that, look, 8.5 out of the 20 students would actually get a score 21 or less. So them could have get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, go straight up to the 21. All of this, all of the section here represent 8 students. See here? 8 students take up, 8.5 students take up the whole of this space. So the probability of choosing somebody that get 21, a score of 21 or less, would be the 8.5 out of the 20. Right?